Simplifying rational expressions. Remember, rational expressions just means fractions. So when simplifying these, you're going to do a lot of the same processes of fractions. Now, if you were in class, I would ask you to simplify the following fractions. 5 over 15, which is this. 5 is 5 times 1. 15 is 5 times 3. The common factors I can cancel out are the 5s, so the answer is 1/3. Now, you probably don't think of it that way, but in reality, that's really what you're doing, is canceling out common multiples. So like 16 over 36, I got 4 times 4 is 16. 4 times 9 is 36. Cancel out your 4s, you're left with 4 over 9. Notice, between my factors, I have multiplication. It's not like I can take 5 over 15 and rewrite the 15 into something like 10 plus 5 and cross out these to get 1 plus 2, and there's my 3. No, that is bad. We only cancel out when there's multiplication present. So when I'm factoring out, or when I am simplifying a polynomial rational expression, I'm going to make sure everything is factored. Like on the bottom, everything here on the bottom is going to have a factor of 2x, or I'm sorry, just x. So I take out the x on the bottom, and I'm left with 2x plus 3. And on the top, I've got 4x squared. Okay, well, x squared is x times x. That's not quite showing up real well. So I can take a factor of x out of the top and the bottom, and I'm left with 4x plus over 2x plus 3. And I am done, because that's a plus right there, and I can't touch anything on the 2x plus 3 because of that plus. Okay, factor first. Again, if this is in class, I'd be saying factor, 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 again and again and again and again. Okay, so I factor the top part of the fraction. I got x minus 5, x plus 3. On the bottom, I've got x minus 5 and x plus 1. These are common factors. I'm left with x plus 3 over x plus 1. Now, I do not cross off any of those x's because they're separated with a plus 3. X plus 3 is a totally different number from x plus 1. Okay, again, I'm going to factor the numerator. So, difference of two squares, x minus 4, x plus 4. Now, because my numerator was that factoring, I'm going to try on the bottom to try to get that to factor out to be the exact same thing. So factors of negative 12 that add up to be 3, x plus 4 and x minus 3. There we go. The x plus 4's cancel out, and we're left with x minus 4 over x minus 3. But factor first. Factor before you make any sort of decision on what to cancel out. Okay, so again, on the top or the bottom, and it doesn't matter which one you start with first. You pick whichever one you're most comfortable with. I'm going to go with the denominator first because I know that's a pattern of difference of two squares. Okay, so on the top, I'm trying to get an x plus 1 or an x minus 1. And the top is x minus 1 times x minus 1, factors of positive 1 that add up to be a negative 2. So the x minus 1's cancel out, and I'm left with x minus 1 over x plus 1. Okay, hopefully I'm not going too fast. I'm not trying to, but again, you need to factor